Have you ever wondered what existed before the Big Bang? The Big Bang theory, a term we've heard numerous times in our lives, is the prevailing cosmological model explaining the inception of the universe. It suggests that around 13.8 billion years ago, the universe burst into existence from an incredibly dense and hot state, expanding rapidly like a balloon inflating. Over time, this expansion led to the formation of galaxies, stars, and everything else we see in the cosmos today. But here's the catch. The Big Bang theory doesn't explain what was there before that colossal explosion. It's like a movie that starts in the middle, leaving us to wonder about the scenes that preceded the action. This is the Big Bang Conundrum, the question that has puzzled physicists and cosmologists for decades. What existed before the Big Bang? Well, the answer isn't straightforward, and that's what makes it fascinating. Some scientists propose that our universe is just one of an infinite number of universes, collectively known as the multiverse. Others suggest that the universe oscillates between periods of expansion and contraction in a cycle of big bangs and big crunches. And then there are theories that venture into the realm of quantum mechanics, proposing that the universe may have sprung from a quantum fluctuation in the vacuum of space. These theories, while intriguing, are highly speculative and difficult to test. So, where does this leave us? Well, as of now, we don't have a definitive answer. But don't be disheartened. The beauty of science is in the pursuit of knowledge, in the challenge of unraveling the mysteries of the cosmos. Let's dive into this perplexing question and explore some of the leading theories. The journey we're about to embark on may not provide a definitive answer, but it will certainly take us to the very edge of our understanding of the universe. So, buckle up and get ready for a journey through time and space as we attempt to unravel the mysteries of the Big Bang and beyond. To start with, we need to understand how material or physical matter first came into existence. The universe, as we know it, is composed of atoms and molecules, the building blocks of matter. However, in the earliest stages of the Big Bang, there wasn't a single atom or molecule in sight, not for hundreds of thousands of years afterwards. So how exactly did these atoms and molecules come into being? The answer lies in the fundamental particles that predate atoms. The first long-lived matter particles were protons and neutrons, which together make up the atomic nucleus. These particles came into existence around 1/10,000th of a second after the Big Bang. Before this point, there was no material in the familiar sense of the word. The universe was a hot, dense sea of energy with no stable matter. However, as the universe expanded and cooled, conditions became conducive for complex matter to form. The first protons and neutrons formed out of simpler particles, setting the stage for the eventual creation of atoms. But the story doesn't end there. These first atoms were mostly hydrogen and helium, the lightest elements in the universe. To create heavier elements, such as carbon and oxygen, we needed the heat and pressure found inside stars. Once formed, these atoms were later fused into heavier elements inside the nuclear furnaces of stars. Over billions of years, the death and birth of stars scattered these heavier elements throughout the universe, eventually leading to the diverse array of elements we see today. So we've traced the origin of matter from the Big Bang to the formation of atoms and molecules. It's a story of energy transforming into matter, of simplicity evolving into complexity. But this doesn't address our main question. Did something come from nothing? Let's take a step further back in time to the grand unified Epoch. We're diving deep into the realm of speculative physics now, as we can't generate enough energy in our experiments to probe the processes that occurred then. Nevertheless, a plausible hypothesis paints the picture of a world made up of a soup of short-lived elementary particles, including the building blocks of protons and neutrons, the quarks. This was a world where matter and antimatter existed in roughly equal quantities. Now you might be wondering, what is antimatter? Well, each type of matter particle, like the quark, has an antimatter mirror image companion. This mirror image is nearly identical to the matter particle with just a slight difference. It's like looking at your reflection in the mirror. It's you, but not quite you. But there's an interesting twist to this matter-antimatter story. When a matter particle meets its antimatter counterpart, they annihilate each other in a flash of energy. It's a constant cycle of creation and destruction, a dance of existence and non-existence. So, If we were to take a snapshot of the grand unified epoch, we'd see a cosmic soup where particles are continually being born, only to vanish in the next moment. It's a chaotic and fascinating scene, a testament to the dynamic nature of our universe. But here's the million-dollar question. Where did these particles come from? How did they appear in the first place? It's a question that has puzzled scientists for decades, and one that takes us to the very boundaries of our understanding of the universe. We've traveled back to the grand unified epoch, witnessed the birth and death of particles, and discovered the strange world of matter and antimatter. But our journey doesn't end here. There's still a lot more to uncover about the origins of our universe, so buckle up as we delve even deeper into the mysteries of the cosmos. But where did these particles originate from? The answer might lie in the realm of quantum field theory. Quantum field theory, or QFT for short, is a branch of physics that combines the principles of quantum mechanics and the theory of relativity. It's a bit like a cosmic rulebook, providing a framework that describes how particles interact and behave. Now let's talk about the concept of energy fluctuations in a vacuum. It's a little counterintuitive, but according to QFT, a vacuum isn't truly empty, it's teeming with activity, with energy levels fluctuating and particles and antiparticles constantly appearing and disappearing. This is what we call the quantum vacuum. Imagine the universe as a sea, and particles as waves that rise and fall. The energy fluctuations are the wind that creates these waves. Sometimes the wind is strong enough to create a big wave, a particle, that momentarily stands out from the rest. But just as quickly as it forms, it disappears, merging back into the sea. This process of particles popping out and disappearing might seem random, but it's governed by Heisenberg's uncertainty principle, which states that you can't precisely know both the position and momentum of a particle at the same time. This principle allows for these temporary particles, known as virtual particles, to borrow energy from the universe, pop into existence, and then disappear, repaying their energy debt. These virtual particles aren't just theoretical, they've been detected in experiments and have real effects on the world around us. For example, they're responsible for the Casimir effect, where two uncharged metal plates in a vacuum are drawn together because of the virtual particles popping in and out of existence around them. So it's possible that the universe as we know it originated from these energy fluctuations in the quantum vacuum, with the Big Bang being the result of a particularly significant fluctuation. This might sound like a mathematical quirk, but it's a fundamental part of our understanding of the universe. So what was there before the Big Bang? There are several theories that scientists are exploring. One of these is the cyclic model, a theory that suggests our universe is just one phase in an infinite series of cosmic cycles. Each cycle begins with a Big Bang, followed by a period of expansion and cooling. After trillions of years, the universe contracts in a big crunch, only to bang again. The universe, in this perspective, is akin to a phoenix, eternally reborn from its own ashes. Another theory that's been gaining traction is the multiverse theory. This posits that our universe is not alone, but one of a potentially infinite number of universes, each with its own laws of physics. The Big Bang in this scenario could be just a local event, a bubble of space-time that inflated within a larger multiverse. Then there's the quantum gravity era theory. This presents a pre-Big Bang phase where gravity, as we understand it, did not yet exist. Instead, quantum effects dominated, creating a state of space-time foam where wormholes and particles were constantly forming and annihilating. There's also the no-boundary proposal by physicist Stephen Hawking. This suggests that time did not exist before the Big Bang. Instead, the universe began as a singularity, where all the laws of physics as we know them break down. Time, in this model, would be more like a dimension of space, having no beginning or end. Each of these theories presents a different answer to the question of what existed before the Big Bang, each with their own unique implications about the nature of our universe. As we continue to explore these ideas and gather more data, we inch closer to unraveling the mysteries of our cosmic origins. While we may never know for certain what existed before the Big Bang, it's a question that continues to drive scientific exploration and deepen our understanding of the universe.